Okay, so similar to what we did when we were plotting the display shape, for the beam end forces, we need to take this list and basically look at 6 forces, so 3 at each node for each element. So I'll do the partition list first of all. So we'll take that there, and this time we want to partition it every 6. And what I'm also going to do that we don't necessarily have to do, but I'm just going to simplify the output from there. I'm going to run that all into a list item selector. I'm going to turn off the wrap. Again, probably don't have to do this, but it just makes kind of bugs and things a little bit easier to spot if they are there. And then I want a total of 6 outputs from there. And at this stage, those outputs, what I want to do, I'm just referring to going from the local element axis to the cross-section axes. So I would look up the table that I went through in the lecture and is in the notes. But basically, for some of these, we just want the negative, and for some, we just want the actual value. So we want the negative for those two, actual value, so just number here for these ones. And obviously we're flipping basically between one end and the other. So finally we want the negative down for the moment at the second node. So just try and tidy all of these up a little bit. I'll leave that one roughly where it is. Okay. Okay, so we can just align them all and then match them all up in that direction as well. Now, what I want to do then is, because I don't actually want to complete all of these components 3 different times, I'm going to use what's called a gate and then a stream, or a stream filter, in fact. So what I want is I only want the information for axial force, shear force or bending moment, and I'm just going to make it so that I can plot one of those diagrams at a time. So I'm setting up the 2 stream filters here. I want an extra output from each of these, so we'll do that. And then just to keep it consistent with the canvas that I've given you, I notice I've used relays on that, so I will try and do 6 of those quite quickly, and we want them just lining up here. So like so, let's connect them all up and try and just tidy these so that they're taking the information roughly in a horizontal fancy wire. And then I will just align all of them. Okay, so we will connect these up like so. So basically, obviously this is really node A here, and this is node B that we're interested in. And then I am going to use something called I think it's called a selection menu, but I may just have to check on that. Okay, so what I wanted is something that I found in the input. So it's basically this, so a value list. And what that allows me to do is, just on the canvas, I can select any of the values in here. So I'm going to double click basically, and I'm going to say, okay, either I want the axial force So that would be just thinking about what axial force is. So obviously that's Fx, and that would be in newtons. Or I want the shear force, and I know that that's Vz, and that will be in newtons. Or I want the bending moment, and that's My in the cross-section axis system, and obviously that is in Newton millimeters. And then what I want to do is just to say what number does that correspond with. So we have 0 or 1 or 2 for the gates, like so. So not done that quite right. Okay, so I just needed to edit how I was writing that. So this should be equal to those values. And let's just see, yeah. So now if I go through, it will let me select the shear force, the axial force, or the bending moment. I'll just go in and correct that unit on the shear force. And basically what it then gives me out is the value associated with that text. So because shear force is the one that we will look at first, I can take that to the gate output like so. And then what we can begin to do is the way we're going to generate the output is we're basically going to generate some vectors which will be related to the element direction, and then will allow us to plot a rectangle that will be, or rather a quadrilateral, that will then just allow us to represent the values that we're interested in. Okay, so I'm also actually going to use another value choice or value list, because I want to either be able to plot these internal force diagrams on the undeformed or the deformed shape. So I'm going to say don't need those other two, but I'll say that I can either have undeformed, so I'm going to set that equal to 0, or I can say that I want the deformed shape, so I'll set that equal to 1. So then we have another value list like so. I'm going to set up another stream filter, so like so, and we'll run that into there. So what we're going to do is we want the elements either from the deformed or the undeformed shape. So for undeformed, I'm just going to zoom up here. So I want the original elements, or for the deformed, and just noting that that will end up using this magnification factor. For the deformed, which is what's going to go in input 1 there, I can use the displaced elements like so. Just to avoid having these sort of cluttering the place up, I'm going to hide their wires as well. Okay, so I'm then just going to make sure we know that we have a line. So that's like so there. And what I'm going to do is I effectively want to generate the local y-axis, and that's then going to allow me to decide how I'm plotting the values. So in order to do that, I'm going to have just a unit z axis. I will make then the elements into vectors. and these are effectively my x-axis. So we'll just call them x-axis. And then I am going to do the cross product, or let me just check. So again, I will find the correct component. Okay, so here's the cross product. I just needed to wait a little longer to find it. So this does the cross product of two vectors, and what that will do is it allows me to define the y-axis. So that's the vector coming out like so. So I'll put that also as a vector, and I'll just label that. So we have the y-axis there. So what we then want to do is just start to construct a series of points, which is how we're going to deal with the parallelograms. So I'm going to take the endpoints of each element effectively. So that'll give me 2 of the points, and then I'm going to use a movement to generate the other points. So what I want to do is I'm going to move each of those points at the ends of the elements, and I'm going to need to move them by a value that's associated with the internal force that I'm plotting. And I now have my vector for the y-axis, but one thing that I can do is I can just add a magnification factor there as well when I plot these. So I'll just do this at the moment between 0.1 and 10. Again, this is something that we might change, but I'll call this magnification factor again. So what we can then do is just have some multiplication elements. I can zoom in and just add another input to these. Like so. And then what we're doing here, so I'm going to bring this back so that basically all of our inputs or all of the things we can alter are over here. But I'm going to connect these up. I can take the values that I'm interested in, and I'm just going to flatten all of these so they're just in a nice list for us to deal with. Flatten all of them, and then you can see what I'm doing is I'm taking my y-axis up here. So I'm then going to move the points like so, and the points I want are at the moment down here. So I'm just going to introduce a point sort of storage component basically. So we'll run that up. That's the geometry I want. Again, control just allows me to remove that. And this is the vector that I'm moving everything by. So doing the same then for the endpoint. Just bringing that up here. And again, this is the vector that I actually want to move everything by. So what that's going to allow me to do is I can now construct this quadrilateral from those points. So I think that's a surface option. So 4-point surface is actually what we want. So I'm going to directly connect this one into there. Then we want this one then we're going to have this one coming in there, and then finally this one coming in there. So what you can actually now see over in the Rhino side, so I'm managing to generate these. They look a little bit funny because I've used this deformed surface here. So if I go back to undeformed, you can see this then has the shape that I'm expecting here. So the last thing that I want to do is I'd like to add in some text just to try and make sense of some of these diagrams. So on the text, this has a location, the actual text that we want to display, and then the color. So the location I'm going to put basically up at the top of each diagram, so kind of there basically on each of these. In terms of the text, I'm going to adopt a particular format, so I'm going to put this in as if it was an expression, and the format that I'm going to use, so you will find online sort of details about how you can decide on this format, but basically I'm just going to put it in like so, and that will output something in the form that we want it. I want to include the unit, so that's why I've done this expression. So I'm going to use a panel to decide on the unit, and again we'll just make that into multi-line data, and I'll call it unit there. So this is just something that we're going to add to our text, so Newton, 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 millimeter in there. So that I'm going to feed in to this part here, and then what I want to do is I want to take my value, so I'm only going to plot one of the values, but I'm going to feed that into there, and here what I want is I want to select from this list of the units that I've got, and I will use the gate output to select what I want from there. So what we can see here, if I just quickly put a panel on, is we can see how all of that information is going to be outputted. So I can now just, I'm going to stretch this out over here, but I can now add that in as the tag. So if we zoom in, we can see that, and we can plot the shape basically along here. And then almost the final thing that I want to do, I'm just going to use what's called a color swatch from, maybe it's just called a swatch. Yeah, so color swatch actually spelt correctly was the mistake I was making there. And I want to change this actually to black, because I would like my text to be in black. So we can just select those two. So just the final tidy up here. So I'm going to call this diagram and values, and then I'm going to select all of this here. Just going to drag it down a little bit, so put it in the group, then actually we'll just drag that group, and then the group I'm going to call plotting the axial force Fx shear force Vz or bending moment My diagrams. So what we now have is, so we've shown the shear force. I'll just highlight that again. But we can very easily click, for example, to the bending moment. And okay, so the bending moment is a little bit different. So let's dial down the magnification factor. So let's actually take that down to say 0.001. See if it will let me go to that. Okay, so we just need, okay, so I'm just going to edit the number of digits that were allowed. So maybe if I change that to 0.01, let's just check now. It's still not quite doing what I wanted it to do. See if it will let me do this. So I'm just going to change the maximum. Okay, so still extremely large, and we'll just come to deal with that in a second. But what you can see is that it has the shape we were expecting. So that is, it's linearly decreasing as we go down. So what I'm going to do is I'm actually going to change the maximum to 0.1. Let me just scale that down there. And if we zoom in, we can just about, so there's something slightly odd going on that I'll just resolve and check back on what's happening there. Okay, so the issue was just that I'd forgotten to flatten this input here. So if we now go, you can see that everything is appearing as we would expect. And so we have a complete analysis package, basically. So we've done all of the pre-processing, we've done the actual structural analysis part, and we've done a fair amount of post-processing. You'll see there is another file where I do contour plots, and I'll make videos available for them quite soon. But I think this is plenty to deal with so far. And as I say, you know, in a relatively short space of time, we've produced quite a generalizable piece of structural analysis software that we can use pretty much for any structure that we can represent in 2 dimensions using beam elements. So I will see you for the next video. Thanks.